Natural physics is a concept I developed that explains in down-to-earth scenarios how the principles of physics could have come about from observing nature. Each episode begins with a scenario followed by an example to illustrate the application of these principles in futuristic research at the frontiers of science, such as my astrophysics research, and then concludes with an exploration of how these same principles could have very well been used by ancient cultures and civilizations. Mathematics is naturally encountered and incorporated as the exciting and fun tool of science that it is. Science is the window into our amazing world of nature, and mathematics is the tool to open that window. Natural physics encompasses current, futuristic, and ancient physics, and ties them together by the principles of physics that are common threads running throughout each. Greetings, I'm Leroy Larry. Welcome to our Natural Physics Variety Show, live from Costa Rica. Be around me. What made the Hulk the Hulk? Gamma rays. Gamma rays are the most powerful form of energy known to exist in nature. More powerful than microwaves and X-rays, gamma rays come from cosmic rays. Cosmic rays were first discovered in the 1920s, and no one knows where cosmic rays come from.
Gamma rays are very highly energetic photons and are at the extreme end of the electromagnetic spectrum. The visible range in which we see is a small part of this spectrum. Just as a group of 6 runners will break apart when running from the beach into the ocean, a beam of light separates into the 6 primary colors of red, orange, yellow, green, blue, and violet because these colors travel at different velocities when going from one medium into another. Cosmic rays are high-energy protons, ions, and electrons that astrophysicists believe are produced when a star explodes into a supernova. As the shock wave from the explosion expands out into space, it encounters protons, ions, and electrons. Its magnetic field pushes them up to very high speeds, and they gain energy by repeatedly crossing the shock. The process, called diffusive shock acceleration, or DSA, is thought to be facilitated by scattering off magnetic turbulences downstream and irregularities upstream. Charged particles change trajectories when they encounter a magnetic field, making it impossible to directly determine where cosmic rays come from. The source of gamma rays are traceable because photons have no charge and are unaffected by a magnetic field. Cosmic rays can reach energies up to 10 to the 21st electron volts, and below 10 to the 15th electron volts are thought to be of galactic origin. The most promising sources of galactic cosmic rays are supernova remnants, or SNRs. They are not only energetically favorable, but also provide a mechanism to accelerate particles to very high energies. An important window of observations in the range from 100 mega to 300 giga electron volts has been opened with the launch of the Fermi Observatory. Much of the gamma ray emission can be explained by Bremsstrahlung emission and inverse Compton scattering. However, the model cannot fit a distinct feature at giga electron volt energies, which can be accounted for by adding a pion component to the model, providing evidence for cosmic ray production. Despite all the findings that link SNRs with high energy electrons, direct evidence for the acceleration of ions by these objects is still lacking. In order to find a signature for proton acceleration, studying the photon spectrum of the sources at gamma ray energies becomes fundamental. It is expected that a fraction of the high energy emission would be caused by the decay of neutral pions produced through collisions of accelerated protons with cold ambient protons and ions. If the astrophysicists can prove that the accelerated protons are producing the gamma rays, then the mystery of cosmic rays will be solved.
Remember, FAT, spelled all caps, PHAT, physics with attitude, enjoying physics as the window into our amazing world of nature and mathematics as the tool to open that window. So tune in next week, same fat time, same fat channel.